So in problem type 1 of this topic, all three equations had all three variables. So in this problem type, every equation won't have all three variables. So sometimes we have to come up with something a little more creative. So what I'm going to do is I'm going to take this top equation and I'm going to solve it for y. Once I've solved that for y, I'm going to take this second equation and solve it for x. So notice now I have both x and y in terms of z. So I'm going to go into the third equation and replace x with the expression for x and y with the expression for y. So now I just have one equation with one variable, so I can solve for z. Now that I know what z is, I can go back up into my y equation, replace z with its value, and find the value for y. And then go into my x equation, replace the z with its value, and find the value of x. So there's my ordered triplet. They don't always work like that, though. If you look at this one, only that third equation doesn't have all three variables. So I can label them 1, 2, 3, like we did on problem type 1. And here I'm going to use 1 and 2 to get rid of the x, or to eliminate the x. Notice I can just go ahead and add them together, so the x is gone. And I'll go ahead and label that equation 4, just because I think it's easier to go ahead and label them to be able to think about what we're doing. But now I can take equation 3 and equation 4, right? Now, another way, we could multiply equation 3 by 3 and eliminate that way. But this one works so nicely to just solve the equation for y. So now that I've solved equation 3 for y, I can plug that expression for y into equation 4 and solve for z. Then, now that I know what z is, I can plug the value for z into equation 3 and solve for y. And then I can take z and the value for y and plug it into equation 1 and solve for x. I could have also plugged that into equation 2 and solved for x. It wouldn't have mattered. And here's our solution.